Kites. What we're talking about today. Are you with me in the notes? Kites? Okay. Did I miss anyone who wasn't here Monday with the notes package? Okay, you notes, come on up.
No, I got it.
Oh, you got one? Okay, that's what I wanted to know, is if anyone still didn't have notes. Okay. So, doesn't that picture make like life was wonderful?
Yeah, no,
I never liked
Kite.
You flying
Okay. So let's talk. All right, guys. Guys.
Yeah.
Tune it in. All right. I'm not sure whether we named these kites after the geometry kites or the other way around. I'm not sure. But let's talk about the geometric definition of a kite. Carly gave to us a kite is a quadrilateral with two pairs of consecutive congruent sides. Okay? That means the congruent sides are right next to each other. That's different than any other quadrilateral. A lot of quadrilaterals have opposite congruent sides, so like the two that are across from each other. This is the only one that has consecutive congruent sides. So here's what it looks like, and take note of the markings, okay, that these two sides are congruent and these two are congruent. Don't get fooled into thinking, though, every kite is going to stand up and down like that. All right, it is possible for a kite to be turned sideways, like you could have these two be congruent and then these two be congruent, and that would still be considered to be a kite. Okay?
That's a beautiful kite.
Leave it alone.
Let's look at Star Wars.
I marked them to do it. You have to believe me, all right? So,
Lasers. So you could.
oh my gosh. All right. The ends of the kite. When I'm talking about the ends of the kite, it's the vertices that fall between the congruent sides. So if these two sides are congruent, this would be considered an end of the kite. If these two are congruent, this would be considered an end. So in this figure, those two are the ends. And you want to kind of darken those in. The ends are important because kites only have, well, how many lines of symmetry would a kite have?
One.
Just one, right? And the line of symmetry runs straight through those 2 points, okay? And that line of symmetry is helpful because remember, everything, like for example, if this is our line of symmetry, this angle is going to be congruent to that angle, all right? This, when it's cut in half, this little angle is going to be congruent to that little angle. All right, so those lines of symmetry are helpful, and the ends tell you sort of where that line of symmetry is. Okay, anyone still writing? Let's talk about that symmetry. So like I said, the line that goes through the ends, so the line that would run straight through here, is the line of symmetry for a kite. And we call that a symmetry diagonal. Remember, the diagonals are when you connect the vertices like across the figure. So that particular line is a diagonal, and it's also a line of symmetry, so we call it symmetry diagonal. So that red line is considered to be a line of symmetry. And so then the diagonal that goes from here to here is the symmetry diagonal. So let's talk about those diagonals. Here's a kite with both diagonals drawn in. Somebody make an observation for me. What do you think is true about those diagonals? Keegan?
They're perpendicular.
They are perpendicular, you are right. And not only are they perpendicular, but one of them bisects the other. Now they don't both get bisected, but do you see, like, this line cuts this segment in half, so this little piece would be congruent to this little piece. So we would say this is the perpendicular bisector of this. What the kite diagonal theorem says. It says the symmetry diagonal of a kite, which is that one that runs between the ends. Okay, let's see. I'm going to darken that in a little bit. The symmetry diagonal is this one. Oh, I wanted that to be thicker. Let's try that again. There we go. This one is the symmetry diagonal, and that is the perpendicular bisector of the other one. Go a different color. So we know that it makes a right angle here, and we know that these two pieces are congruent. And that might be a little hard to see. Oh, actually, it looks better up there because it doesn't on my screen. So when you have that symmetry diagonal, that cuts the other diagonal in half. Just be careful. With a kite, it doesn't happen the other way around. This one does not get cut in half. Okay, because that's not a symmetry diagonal.
The line one, the long one cuts the short one.
Right. Well, it's possible though to have it drawn where this one,
The one that splits it in half.
right,
That's
this, yes, the symmetry line cuts the other one in half. Yep, because it's possible to draw it the other way around too. You should know that symmetry diagonal bisects the angles at the ends of the kite. So just a minute ago we said this was a right angle. Sorry, mine just got erased. And these two are congruent. And then we also know that these little angles up here are congruent to each other, and these little angles down here are congruent to each other. However, we don't know that these are congruent to these. They're going to be two different angle measures because this is not a line of symmetry. So this angle does not match this angle. Okay, but these two little guys are equal and these two little guys are equal. Are these two equal? This one and this one? Let me show you again. These two? Are these two equal? No, because this is not a line of symmetry. Okay? So, think about this. A kite has two pairs of congruent sides that are next to each other. So like it has these two congruent and these two congruent. If a figure had all four sides congruent, would that still count as a kite? Would it still have 2 and 2?
Oh, yeah.
Yeah, it sure would. Okay? So yes, if it had all four sides congruent, it would still be called a kite. What do we call that if all four sides are congruent?
Square.
Careful.
Rhombus.
Rhombus, yes. Square is too specific. A square is a type of rhombus, all right? But a rhombus type of kite. And that means that everything we just learned about kites also works in rhombuses, except better. It works more in rhombuses, and I'll show you what I mean by that in just a minute. And then, to go back to what you guys said, a square is a type of rhombus, so this would also be true in a square. Everything that we're talking about is also true in a square. Okay? So on a rhombus, the big difference you run into, where's my red one again? Remember I told you that the ends are between the congruent sides. Well, if all of the sides are congruent, then all of the corners are ends, and that means everything is a line of symmetry. So this is a line of symmetry, if I actually drew it through the corner there, and this is a line of symmetry. So in a rhombus, you do get both lines of symmetry. Remember I was showing you a second ago in a kite, the short one in that picture we had a second ago was not a line of symmetry. In a rhombus it is, okay, because all four sides are equal this time. So what do we know about the diagonals in a rhombus? Well, they have to do the same thing that the diagonals in a kite do. So each diagonal of a rhombus is a perpendicular bisector of the other. This time they both get bisected because they're both lines of symmetry.
Wait, what does that say on the left?
It says each diagonal of a rhombus is a perpendicular bisector of the other. And we'll draw that in a picture in a minute. So I've given you a picture here of a rhombus with the diagonals drawn in. And so here's what you know in a rhombus. You know that in the middle they make a right angle. Okay? You also know that these pieces are equal and these pieces are equal. Okay, so this time they both get bisected. Didn't we also learn that the diagonal in a kite bisects the angles at the ends? Right? So these little angles would be equal, these little ones would be equal, these would be equal, and these would be equal. Let me mark all those. So These and these would be equal. By the way, would these two be equal to these two this time? In a rhombus? If, let's see, if this is a line of symmetry, doesn't it make sense that this angle would have to match up with this angle? So these two little ones would have to match up with these two little ones. Those two are going to be equal. And then you also know that these two here are going to equal these two down here. So a lot of stuff you know, just from me telling you something is a rhombus, there's a lot of information kind of hidden in there. Do you have all those markings? Okay, so here's an example, and this is similar to stuff you'll see on your homework. Okay, it says given Kite is a kite. Amazing. With ends K and T. So that's what tells you that this is your line of symmetry right here. Okay, because it goes between the ends. Right? And that tells you that these sides would have to be congruent and these ones would have to be congruent. As soon as it starts rattling off all this information, I'm going to start writing it on my diagram. So it tells me that EL is equal to 10, right? So this length is equal to 10. EKT, so that would be from E to K to T. So that's talking about this angle here. EKT is this angle. That one's going to be 43. And ITK is this one down here, 24. Okay. Now it wants me to find IKT. That's so funny.
Wait, how would they be the same?
Because this is a kite. So this big angle at the top does not match this angle at the bottom. Okay, and maybe let me draw that. I mean, that kite, they look like they almost could be, but if I drew a really kind of dramatic kite, like something like that, and I do this, these angles don't match these angles.
We don't
Okay.
I L equal E and L.
Yes,
That's the line.
yes. So that length from I to L would also be 10. Yeah. And that's, I think, the last question on there. It's on my stylus somewhere. Okay, so IKT would be from I to K to T. So that's looking for this angle. What do I know about this angle? It's going to have to be 43, yeah, because these two are going to be equal to each other. This is a line of symmetry. So this would be 43 degrees. Okay. ETI. ETI. So that's looking for this whole big angle. What would that be?
48.
How do you know?
So you add the 24.
Okay, so we know this one would have to be 24 as well. So we would do 24 plus 24 and get 48. All right, LIK. This one is a tough one. LIK is right here. I'm actually going to zoom in on that picture a little bit so we can see it. How would we find this angle? Gabby?
90 plus 43, and then subtract that from
Where are you getting 90 from?
and that's what we do.
Good. This is a kite, so we know this makes a right angle right here. So if I look at, let's see, I want to make sure you see what I'm seeing. If I look at this triangle here as its own little triangle, I know that angles would have to add up to 180. So I would do 90 plus 43 and subtract from 180 to get that angle. Let's see, I'm going to shrink back down. So I'm going to do 180, whoa, minus 90, minus 43, and I think I get 47. Does that sound right? And then the last one, length LI, that's this right here. Luke, you already told me this one. What would it be?
10.
10. Okay, because this is a perpendicular bisector, so this piece and this piece must be equal to each other. Okay. What if I asked you for EI, the whole length? Would you be able to do that? Sure. Yes. Would be fun. Good on that one? All right, the next page is talking about a rhombus. There's even more that we know about it ahead of time. All right, ABCD is a rhombus, and angle ACD is 23 degrees. So ACD would be this one right here. I will tell you, I borrowed this picture from like a big clip art gallery. I don't think it's drawn to scale. Not that you're used to things being drawn to scale since I draw them for you, but just so you know, there's some stuff in here that you're going to be like, really, I don't believe you that that's true, and it is. So, angle ACB would be this one. What's the measure of that angle? 23. Okay. In a rhombus, the diagonals bisect both angles. So you draw that diagonal and it cuts this angle in half and this angle in half. And then you draw the other diagonal in and it cuts those two in half. Angle DAC. All right, so that is, where is it? DAC would be this one. What would the measure of that angle be? And be prepared, I'm going to ask you why. Blake, go ahead.
23.
How do you know?
Because it, DB is a line of symmetry.
Good. Okay, so DB is a line of symmetry. All right, so I could fold it in half right there, and this angle should line up with that angle. So yes, it would be 23. Anyone have another rationale for why that'd be 23? Because I could justify it about 100 ways. No other thoughts? Okay, I want to point this out to you. It would be perfectly fine to justify it the way Blake did. Like if I told you I wanted you to justify, that reasoning would be perfect. Okay, but there's something that's going to come up in problems like this that you're going to need to know this for. So I want to point out, if I look at this triangle here, like the top half,
It's isosceles.
why is it isosceles?
Because it back. Or, no, because they're
Okay, how did I didn't know they were congruent a minute ago though, right? So how do I know this triangle's isosceles without looking at those angles? Because I didn't know that. That's what I'm trying to justify. Because it's a rhombus, so these sides are congruent, right?
yeah,
So those two are congruent, which means the angles are congruent by
it back.
it-bat. Okay, so you could justify that with it-bat also. Okay, angle CBA. CBA is this big one. How are you going to find the measure of that angle?
Subtract 23 times 2.
Okay, so we would know that this angle and this angle are both 23, right? Because they have to match up with these. So these ones are 23, these ones are 23. So if I look at this bottom triangle as its own triangle, I would do 180 minus 23 minus 23. Okay, or just 180 minus 46. Which would be 134, I think. Okay. And angle BDC, which is this guy up here. How would I find that? Again, I can think of a couple different ways to go. Well, 134 would be this whole angle. Remember, 134 was this big one? I just want to know that one. Blake? Yeah, you could say, all right, then I know this whole big angle would also be 134 because this is a line of symmetry. So this big angle is 134, cut it in half, and that's what you're going to get. So I think it's, let's see, 134 divided by 267, I believe. The other thing you could do, similar to what we did with the rhombus a minute ago, you could look at this triangle as its own triangle, and you know it's 90 in the middle. Okay, so you could do 180 minus 90 minus 23. Listen, Mrs. Trigger. Hi. Okay. Yep. Sure. Yep. Yep, nope, it's still going on, as long as our academic activities are not canceled, then yes, it's still going on. Yep. Great. All right, we'll see you then. All right, bye-bye. Sorry, guys. That's it, that was our last example, right? Did we get it all?
Yeah.
We did. Okay, homework, you are looking at Tuesday's homework, okay? So we're shifting everything back there, you're looking at Tuesday's homework, lesson 6-4, okay? So lesson 6-4, if you're looking at the calendar in the front, just make sure you're looking at Tuesday. And that's all stuff on kites, okay?
It's in the book.
Yeah, in the book.